Children, it is a continuation of the solution of the numerical problems in the electricity chapter. Now let us take the numerical problems based on resistance and resistivity. So you take the first question, calculate the resistance of metal wire of length 2 meter and area of cross section 1.55 into 10 power minus 6 m power 2 if the resistivity of the metal is metal is 2.8 into 10 power minus 8 ohm meter. Here what is given? The length of the metal wire is given and the area of the cross section is given and also the resistivity of the metal is given. Now let us write the length of the metal wire. L equals 2m and area of cross section A equals 1.55 into 10 power minus 6 m square. Resistivity equals 2.8 into 10 power minus 8 ohm meter. Now you write the relation R equals. Here what we have to find out? We have to find out the resistance. So you write R equals question mark and write the relation among the resistance, resistivity, length and cross section of a metal wire. That is R equals rho resistivity into L by A. That equals resistivity, you write 2.8 into 10 power minus 8 and L is 2 meter, write 2, that divided by A is 1.55 into 10 power minus 6. Now you write here the decimal point is after 2 digits, here the decimal point is after 1 digit. So make the decimal point equal, that is 155, that is 280. Then into 10 power minus 8 into 2, it is 10 power minus 6. Then you can have 28 to the 56. So 280 into 2 is 560, that divided by 155 into 10 power minus 8 plus, that becomes, if you take this 10 power 6 to numerator, it becomes 10 power 6, that equals 560 divided by 155 into 10 power minus 8 plus 6, and you write 560 divided by 155, or you know that it is divisible by 5. First you divide it by 5. 5 3s are 15, 5 1s are, this is 5 1s are 5 1s are 5 2s are. Then you divide 112 by 31. Know that becomes 13 1 3s are, 31 4s becomes more, 31 3s are. 3 ones are 3 and 3 threes are 9. So 12 minus 3 is 9 and 10 minus 9 is 1, and put the decimal point and put 0. Again you can divide 31 into 6, it becomes 6, and 6 threes are 18. Then what is remaining? 4. Then you write 4 0, 1s are 9 is remaining. Then approximately you can have 3s are, so that is equals to 3.6 you can write. This is enough, you can leave this. 3.6 into 10 power minus 2. 10 power minus 2. Therefore, R equals, you can write 3.6 into 10 power minus 2 ohm. Resistance of the metal wire of length 2 meter and area of cross section 1.55 into 10 power minus 6 m square, and the resistivity of that wire is 2.8 into 10 power minus 8 ohm meter, and that is resistivity is equals to what? 3.6 into 10 power minus 2 ohm. Now let us take the second question. Aluminium wire has radius 0.25 mm and length 75 meter. If the resistance of the wire is 10 ohm, calculate the resistivity of the aluminium. Calculate the resistivity of the aluminium. Here what is given? The radius of the aluminium wire is given and length is given, and also the resistance of that wire is given. What you have to find out? You have to find the resistivity. Here area of the cross section is not given, and in the formula there is area of cross section. So area of cross section is nothing but pi r square. You can write that pi r square. Then you write what are given. Note down that R is given. R equals what? 0.25 mm. 0.25 mm. You must convert that into meter. That is 0.25 into 10 power minus 3 meter. Because you know that 1 mm equals 1 by 1000 meter. That is equals to 10 power 3 meter. So you must multiply it by 10 power minus 3 meter. Then what is given? L is given. So you take L. L is how much? 75 m. And R is given. What is R? 10 ohm. Then what you have to find out? We have to find the resistivity. Resistivity we have to find equals question mark. Then you know the relation here. Resistivity equals R into A by L. R into A by L, because R equals what? That is rho into L by A. So rho becomes, the resistivity becomes RA by L. Then you substitute the values. R is the resistance. What is R? R is 10 and this A is pi R square and L is how much? That is L is 75 m. 75 m. That equals 10 into pi value take 3.14 into R. R is the radius, that is 0.25 into 10 power minus 3 whole square. And also you can write 2 times, that is nothing but write it 2 times, 0.25 into 10 power minus 3, that is nothing but whole square, that divided by 75. Then here then it is 25 threes 25 0.01. Then you take 10 into 3.14 becomes, that is 31.4 into 0.25 into 0.01 divided by 3 into 10 power minus 3 into 10 power minus 3. Then you find the product of these 3. That is, so you take 314 into 25. That is 25 4s are 100, 10 carrying. 25 1s are 25 plus 10, 35, 3 carrying. Then 25 3 is 75 plus 3, 78. And this is 31.4, this is 0.25. So here 1, 2, 3, you will get 7.850. That into 0.1 means 0.01, that equals what? You will get 7850 and 1, 2, 3, 4, 5 digit, that you will get 0.0850. That divided by 3. That divided by 3. So you will get 0.0, 2 is 6, 1 8, 6 is 18, 5, 1 is 3, 2 6, 6 is 3 6 is 18. Again you are going to get 6 6 only. So the whole value you will get 0.02616. 6 you are going to get repetitive into 10 power minus 3 minus 3. Sum of these two. A power m into a power n is equals to a power m plus n. Then it becomes 0.026166 into 10 power minus 6. 10 power minus 6. Then here you can take this 2 before the decimal point, that is 2 means 2.6166 into 10 power minus 6 into, here 2 digits are taken towards the left side, so it becomes 10 power minus 2. Here 2 digits are shifted means you must take 10 power minus 2 as a product. That equals 2 point, you can take 6 2. The 6 is more than 5, so you can take 2.62 into 10 power minus 8. 10 power minus 8 ohm meter. Resistivity equals 2.62 into 10 power minus 8 ohm meter. That is the, here find the resistivity of the aluminium. We got the resistivity of the aluminium is 2.62 into 10 power minus 8 ohm. Now you take the third question. A wire of length L, wire of length L and area of cross section A and area of cross section A was drawn into a wire of double its length by melting it. If its original resistivity and resistance were rho and R. You can write it rho, or you write name it as P and R respectively. What will be its new resistivity and resistance? What will be its new resistivity and resistance? So, a wire of length L and area of cross section A was drawn into a wire of double its length by melting it. If its original resistivity and resistance were rho and R respectively, what will be its new resistivity and resistance? So, let us take here the wire is melted to form the wire of double its length, means the volume will remain same. So, the volume of the wire remains same in both the cases. So, you take volume of the wire remains same in both the cases. So, let us take, then volume is equals to what? Volume equals area of cross section into length. Area of cross section into length. So, here we have taken the second area and second length is A dash and L dash, and original area and original length is AL. So, here you can say that both are equals here. You write equal, and you know that A dash L dash by A dash L dash equals AL. So, you can have that A dash by A is equals to L by L dash, and the length is doubled, means that becomes 1 by 2. Then you take R dash by R. R dash is the new resistance, R is the original resistance, that is equals to what? P of L dash by A dash by rho of L by A, that is Row cancels. Here what is remaining? L dash by L into A by A dash, or otherwise you write it as L dash A into A by L. A by L, that is L dash by L into A by A dash, and the ratio is same here. You know that it is L dash by L means you will get 2 by 1. 2 by 1, and A by A dash is also 2 by 1, that equals 4. So you got R dash by R equals 4, that is R dash equals 4R. R dash equals 4R, that is the resistance becomes 4 times. You got that? Resistance becomes 4 times the original resistance. You know that as the length increases, resistance also increases. So it is doubled, means its resistance becomes 4 times. But the resistivity is same here because the same metal is, in both the cases you have the same metal, so the resistivity remains unchanged. Resistivity remains unchanged. Resistivity remains unchanged. The question may be like this way also. You take, that is the next question, fourth question. A piece of wire of resistance resistance 20 ohm is drawn out so that its length increases to twice its original length. Calculate the resistance of the wire in the new situation. Calculate the resistance of the wire in the new situation. So same thing you can have here. A dash by E equals L by L dash equals, that is 2 by 2L equals 1 by 2. Then you can have the resistance R dash by R is equals to same, that is L dash by A dash by rho L by A, that equals to cancels L dash by L into A by A dash you will get, that equals 2 by 1 into 2 by 1, that equals 4. That is nothing but R dash equals 4 into R, that is R dash is 4 into, what is the original resistance, that is 20 ohm, that becomes 4 into 20 ohm equals 80 ohm. 4 into 20 ohm equals 80 ohm. If you follow the previous one, you can get the idea of this also. Next, let us take the fifth question. A wire of resistance 10 ohm. A wire of resistance 10 ohm is drawn out is drawn out so that its length is thrice its original length. Its length is thrice its original length. Calculate its new resistance. Calculate its new resistance. Here you note that resistivity and density of the wire remains unchanged. Resistivity and density of the wire remains unchanged. Remains unchanged. And also you know that to solve this you must note that the volume of wire remains same in both the cases because same wire is drawn here. You take solution. The volume of wire remains same in both cases. Volume of wire remains same in both cases. Then you take again the same formula for volume. V is equals to area into length, area of cross section into area of cross section into length you take. That is area of cross section is denoted as, for the first case it is A L, and for the second case you take A dash L dash. So say take A dash L dash equals A into L, or A dash L dash equals AL. At the ratio, you know, A dash by A is equals to L by L dash, and it becomes L by L dash means that is 3 times the original. L dash, that is 3L, equals, you will get 1 by 3. L dash equals 1 by 3, or A dash A equals 1 by 3. Next you take the resistance ratio R dash by R equals, and write the formula for R dash and R, that is rho L dash by A dash by rho means resistivity into L by A, resistivity into L dash by A dash divided by resistivity into L by A. That equals rho cancels. They will get L dash by A dash into A by L. A by L, that equals what? L dash by L into A by A dash. So A by A dash. L dash by L becomes 3 by 1, and A by A dash becomes also 3 by 1. So you write that is equals to what? 3 by 1. 3. So both are equals to 3 by 1. So it is 3 by 1 into 3 by 1, that is 9 by 1. So you got that R dash by R is equals to 9 by 1. So R dash equals what? 9R. R dash equals 9R. And here it is given that the wire of the resistance 10 ohm is drawn. So you got that R is equals to 9 into 10 equals 90 ohm. Here the new resistance is 90 ohm. New resistance is 90 ohm. You got the answer. Then you take the next question. It is sixth question. Sixth question you take. A wire has a resistance of 16 ohm. Wire has a resistance of 16 ohm. It is melted and drawn. It is melted and drawn into a wire of half its length. Into a wire of drawn into a wire of half its length. Half its length. Calculate the resistance of the new wire. Calculate the resistance of the new wire. What is the percentage change in the resistance? What is the percentage change in the resistance? So you take, again you can have that in both the cases what remains same? In both the cases volume of wire remains same. So you take the solution. In both the cases volume remains same. Volume remains same. Again you take same A dash L dash and A and L. Then volume equals what? Volume equals same formula you can have A dash L dash, that is new area into length, equals original area into length. A dash L dash equals AL. Area into length. Area into length is the volume. A dash L dash equals A into L. Write the ratio A dash by A equals L by L dash. And you know that is melted into drawn the wire of half its length. Half its length means you can have L by L dash is L by 2. L dash is L by 2, that equals L into what you can have 2 by L equals 2. So you got that is A dash by A equals L by L dash equals 2 by 1 you got. 2 by 1. Then you write the formula for resistance. So you write R dash by R is equals to R dash by R is rho into L dash by A dash, again rho into L by A. Again you know that this cancels. What you will get? L dash by A dash into A by L, and that equals. So L dash by A dash, you write L dash by L into A by A dash. A by A dash. Here L by L dash. L by L dash. L by L dash is 2 by 1. So L dash by L is 1 by 2. And A dash by A is 2 by 1. Here you need A by A dash. So you take the reciprocal, that is again it is also 1 by 2. That equals 1 by 4 you got. that is r dash by r equals 1 by 4. You got r dash by r equals 1 by 4. Then r dash equals r by 4. Then what is the original resistance? The resistance is 16 ohm. R is equals to 16 ohm. So you take r dash equals 16 by 4. 4 ones are 4 fours are. You got 4 ohm. That is also 4 ohm. Then change in resistance you take. Here we have, the question is here, we have to find the percentage in change in resistance. So you take that change in resistance. Change in resistance is what? For R, how much it is changed? R minus R dash. R minus R dash divided by R. And that is, we have to find percentage of change. Percentage of change in the resistance means into 100. Into 100. So originally it was 16. Then you can write 16 minus 4 by 16 into 100. Then 16 minus 4. 16 minus 4 is 12. 12 by 16 into 100. So 4 3s are 4 4s are 4 1s are 4 25s are 25 3s are 75 percentage. So percentage of change in resistance equals, percentage of change in resistance equals 75%. You got the answer. Next, let us take the next question, that is 7th question. You take the 7th question. A silver wire has a diameter of 0.4 mm, diameter of 0.4 mm. It is to be used to make a resistance. It is to be used to make a resistance of 1 ohm. If the resistivity of silver is if the resistivity of silver is 1.6 into 10 power minus 8 ohm meter. Calculate the length of the wire needed. Calculate the length of the wire is needed. Here what is given? A silver wire has a diameter of 0.4 mm. It is to be used to make a resistance of 1 ohm. If the resistivity of silver is 1.6, 10 power minus 8 ohm meter, calculate the length of the wire is needed. Here what are given? Diameter is given, that is 0.4 mm. So R is needed. You write R is equals to what? 0.4 by 2, that equals 0.2 mm. You convert this into meter, that is 0.2 into 10 power minus 3 meter. and resistance is given R equals what? 1 ohm. R equals 1 ohm. Then resistivity. Resistivity is 1.6 into 10 power minus 8 ohm meter. And write the relation among all these, that is R equals, you know that, rho into L by A. Here what is required? We have to find out L. First you write that L equals question mark. L equals question mark. You can write small letter L or capital letter L. So you know that is rho into L by A is equals to resistance. Then L is equals to what? R into A by, it becomes resistance, resistivity. R into A by resistivity. R is given 1. A is pi R square by resistivity. That is L equals 1 into pi is 3.14. R you can have 0.2 into 10 power minus 3. 0.2 into 10 power minus 3 whole square, or you can write it as 2 times into 0.2 into 10 power minus 3, that divided by the resistivity is 1.6 into 10 power minus 8. 1.6 into 10 power minus 8. Then you write L equals, so 1 into 3.14, you can write 3.14. 3.14. Then 0.2 into 0.2. You can write 0.04 divided by 1.6 into 10 power minus 3 into 10 power minus 3 into 10 power 8. You take it to the numerator, that power becomes positive. Then L equals, here 3.14. So remove the decimal point. Here also you take 1 digit 2. Here that becomes 0.4 by 16 into 10 power minus 3 plus 8. The sum of these powers. Then L equals, know that it is 4.1 za, 4 4 za. Then 2 2 za, 2 1 za, 2, 1 is remaining, 2 5 za, 10, 2 7 za. So that becomes 1.57 into 0.1 is, what you are going to get, 0.157 divided by 2 into 10 power minus 3 minus 3 minus 6 plus 8 is 2. Then so you divide 0.157 by 2. 2 point you will get, and 1 is not divisible, write 0. 2 7s are 14, 1 7, 2 8s are 16, 1 0, 2 5s are 10. So you got that L equals 0.0785 into 10 power 2. That is L equals, take these 2 digits to 0, it becomes 7.85 meter. 10 square means 100. So here if you take 2 digits to the left side, that becomes 07.85, that is nothing but 7.85 meter. So what is the length of the wire needed is 7.85 meter. So you write that length of the wire needed is 7.85 meter. Then you take the next question, that is the 8th question, question number 8. Now the question number 8. A wire of length 6 meter and area of cross section 1.7 into 10 power minus 6 m square has a resistance 3 into 10 power minus 2 ohm. Calculate the resistivity of the wire. So here length is given, that is length is 6 meter. Length is 6 meter and area of the cross section is given, that is A is equals to 1.7 into 10 power minus 6 m square, and resistance is given R equals resistance, that is 3 into 10 power minus 2 ohm. Then what we have to find out? We have to find the resistivity, that is resistivity equals question mark, and you write the formula. You know that resistivity into L by A equals rho. So you can write rho equals resistivity equals R into A by L. R into A by L, that is R is 3 into 10 power minus 2. Area of cross section is 1.7 into 10 power minus 6. L is 6 meter. 6 meter. Then you can have 3 ones are 3 twos are 1.7 by 2. That you know that 2.8 are 1.6. 1 is remaining 5. So you got that 0.85 into 10 power minus 2 into 10 power minus 6. Then it is 0.85 into 10 power minus 8 ohm meter. Then you write the resistivity of the wire is resistivity of the wire is 0.85 into 10 power minus 8 ohm meter. 0.85 into 10 power minus 8 ohm meter. Next, let us take the 9th question. Now the question number 9. The resistance of a wire of 0.01 cm. The resistance of a wire of 0.01 cm radius is 10 ohm. Is 10 ohm. If the resistivity of the material of the material of the wire is 50 into 10 power minus 8 ohm meter. Write that is 50 into 10 power minus 8 ohm meter. Find the length of the wire. Find the length of the wire. Here what is given? Resistance of a wire of 0.01 centimeter radius is 10 ohm. So here the radius is given. R equals 0.01 cm. That equals, to convert it into meter, you divide it by 100 or multiply it by 10 power minus 2. So you write 0.01 into 10 power minus 2 meter. then R equals, that is resistance equals 10 ohm, and the resistivity equals 50 into 10 power minus 8 ohm meter. Resistivity is 50 into 10 power minus 8 ohm meter. And why we have to find out? We have to find out what we have to find out? We have to find out the length of the wire. You take small letter L or capital letter L, then you write the formula. Write the relation among these, and you know that is R equals resistivity into length divided by area of cross section. So you write rho into L by A equals resistivity, then L equals R into A by resistivity. So L equals, R is the resistance, that is 10, A is 5 into R square, that divided by resistivity. Resistivity is 50 into 10 power minus 8. 50 into 10 power minus 8. Then you write L equals, can cancel here. Pi is 3.14 into R is 0.01 into 10 power minus 2. 0.01 into 10 power minus 2 whole square you can write, or otherwise you write into 0.01 into 10 power minus 2 divided by 5 into 10 power minus 8. Then L equals, so you write 3.14 into 0.01 into 0.01, that is 0.0001. Two digits. So after the decimal points there are 4 digits, that equals 10 power minus 2 into 10 power minus 2 into 10 power 8. Take this to the numerator, so it becomes 10 power 8, that divided by 5. Then it becomes 5 ones are 5 zeros are 0s are 0s are, and it is 5 2s are. So you write 0.00002, and you write L equals 3.14 into 0.00002 into 10 power minus 2 plus 8. Then it becomes L equals 3.14 into 2. You will get, that is 2 4s are 8, then 2 1s are 2, 8 2, and 3 2s are 6, and 1 2 3 4 5 6 7. Then it is 628, and you must have the 7 digits, 4567.0 into 10 power minus 2 into minus 2 minus 2 minus 4 plus 8 is 4. Then it becomes L equals 10 power 4 is there, so you can take 1 2 3 4 5 6 7 is there, and you take this 4 zeros should be shifted to cancel 10 power 4, that becomes equals 0.628, that is 10 power 4 means 10,000. So 0.000062 into 10,000, you will get 0.028 meter. Then what is the length of the wire? Length of the wire is 0.628 meter. 0.628 meter. Next, let us take the 10th question. Here 9th question is solved. Next, you take the 10th question. A wire of given material having length L and area of cross section E has a resistance of 2 ohm. Resistance of 2 ohm. Find the resistance of another wire of same material having length 2L and area of cross section A by 2 and area of cross section A by 2. Here the wire of given material having length L and cross section A has a resistance of 2 ohm. Find the resistance of another wire of same material having length 2L and area of cross section A by 2. Here the material is same, means the resistivity remains constant. So let us take here L, or you take L1 equals L and L2 equals 2L and A1 equals A and A2 equals A by 2. And now here and you take R1 equals 2 ohm. Then what you have to find out? You have to find out that R2 equals question mark. Now you let us write the ratio, that is R2 by R1. The formula is resistivity into, here R2 is there, means L2 by A2 divided by L1 by A1. That is this is R2, this is R1. Then R2 by R1 is how much? 2 ohm. 2 you write. And this resistivity cancels. L2 is 2L, or otherwise you first you write that is equals to L2 by A2 into A1 by L1. Take the reciprocal of this by taking into. Now you write L2 is 2L, A2 is A by 2 into A1 is A and L1 is L, that is R2 by 2 equals that is 2L, that into becomes 2 by A into A by L. Then AA cancels, LL also cancels. So R2 by 2 is equals to, you will get 4. So R2 equals 8 ohm. R2 equals 8 ohm you got. That is the resistivity of the second wire of the same material with length 2L and cross section A by 2 is 8 ohm. A by 2 is 8 ohm. Now the question number 11. The table given below shows the resistivity of three materials X, Y and Z. Arrange the samples in increasing order of conductivity. And which of this is best conductor? Which are these is best insulator? Here, increasing order of conductivity means decreasing order of resistivity. Here, which one is having highest resistivity? That is 18 into 10 power 17. The sample Z is having high resistivity, so it is having least conductivity. Means it is a best insulator. So you write first answer A, increasing order of conductivity. So that is Z having maximum resistivity 18 into 10 power 17. Next, you compare the power. 10 power minus 9 is there, 10 power minus 6 is there, and it is 11.1 into 10 power minus 6. So second you can write Y, 11.1 into 10 power minus 6, because you know that this is greater than this one, because this is minus 9, this is minus 16 power. So the resistivity of Y is more than the resistivity of X. So Y is having less conductivity. Next you take X. X is having least resistivity, that is 3 into 10 power minus 9. 3 into 10 power minus 9. So here increasing order of conductivity is first Z, after Y, after X. Z, Y, X. That is the increasing order of the conductivity. That is nothing but the decreasing order of the resistivity. Then which of these is best conductor? Here the best conductor is X. Sample X is the best conductor. So write the answer. What is the answer you are going to write? Sample X is best conductor, because it has the least resistivity value. Because it has the least resistivity value. Then C, which are these is the best insulator. You know that the sample having maximum resistivity is the best insulator. So you can take Z. Z is having maximum resistivity, so it is a best insulator. So write sample Z is best insulator. Best insulator best sample. Z is the best insulator because it has maximum resistivity.